Hello, grade 11s. This is Miss Cantlon coming to you through video. The future is now. What we're going to do right now is we're going to work at through 2.1, exploring parallel lines. And the similar diagram is found in your textbook on page 70. So you should be following along. What we're trying to do is we're trying to identify relationships among the measures of angles formed by intersecting lines. So we have an example here. A sports equipment manufacturer builds portable basketball systems like those shown here. These systems can be adjusted to different heights. My diagram's slightly different than yours because I extended the lines for what I'm going to do here. When the adjusting arm is moved, the measures of the angles formed with the backboard and the supporting post change. The adjusting arm forms a transversal. And we have our definition of a transversal right here. A line that intersects two or more other lines at distinct points. So that's what it's called to be a transversal. That's what transversal means. When this basketball net is adjusted, the backboard stays perpendicular to the ground and parallel to the supporting post. That parallel piece is very important here. And that makes sense, right? We're always going to have a basketball net that is parallel to its post. It wouldn't make sense to have a wonky basketball net like that. Okay, so our question, what we're trying to figure out here is when the transversal intersects two parallel lines, how are the angle measures related? And the way we're going to figure that out is with a compass. We're actually going to measure. So if you have a compass, it would be a good idea to get it out. You will need it for this section. And we're going to actually measure this angle. Let's see if I can rotate. You guys can probably do this much faster. There we go. And we can see that this angle is 100 and do I have this in the right spot? I do not. I want to have my point right there and my line is not quite lined up. This is much easier for you guys to do. There we go. So at about 100 and this is 130 and this would be 134 degrees. We're going to measure that other angle formed by the transversal and the parallel line. So lining her up right there. And we can see that this is also 130 is right here. Oops, not what I wanted to do. 134 again. Okay, now let's see, here's another example. Let's see if we can measure the angle formed here by the transversal and the parallel lines. And we're going to rotate and adjust so it's actually in the right spot. Again, this is probably much easier for you guys. This is 71 degrees. And my other angle formed is also 71 degrees. So the question, when a transversal intersects two parallel lines, how do the angle measures related? They are congruent or the same. So this person just goes through and talks about their solution to what they did. They measured and they found the same angles. What I want to do is I want to go back for 1 second. I want to look at, so we have these parallel lines. I want to try and highlight. We have these parallel lines. And if you notice, those angles are kind of like if we drew an F, the angles underneath the F. Similarly here, if we drew, oof, not what I meant to do. If we drew an F, those are the angles underneath the F. That's what it says here. I imagined these angles forming an F. I conjectured that any angle determined by two parallel lines in a transversal that formed an F would be equal. I drew a sketch of what these angles would look like. So again, she is or he, I'm not sure, is making a conjecture that with parallel lines in a transversal, anytime we make an F, anything underneath that F, like I know this is on top here, but it's an upside down F, so underneath maybe the arms of an F, I don't know what you'd call that. Anything with that relationship is going to be equal, equal angles. Okay, so what we're going to do now is we're going to work through this example right here. Okay, use the relationships you observe to predict the measures of as many of the angles of A to G in the diagram as you can. Explain each of your predictions. So what we're looking for is we're looking for that F relationship. So we have two parallel lines in a transversal. So can you see if I drew F like this? Nope, not like that. Yeah, like this. Sorry guys. If I drew an F like this, angle F is in the F position. This is kind of unfortunate with 140. So angle F must be 140 degrees. Okay, let's see what else we can figure out. If we look at angle C and 140 add together to create a straight line, and the angle measurement of a straight line is 180. So therefore, angle C must be 40 degrees to equal 140. And now there's many ways we can go from here. We can use a lot of different properties. You guys have learned before that vertically opposite angles are equal. So angle A must be 40 degrees. And similarly, angle B must be 140 degrees. So there's some relationships there. And we can follow that same pattern here. If F is 140, vertically opposite, E must be 140. And using the property of a complement or adding up to 180 and vertically opposite angles, or we could even use corresponding angles. We can find D to be 40 degrees and G to be 40 degrees. Jonathan made the following conjecture. When a transversal intersects two parallel lines, the corresponding angles are always equal. Do you agree or disagree? Explain using examples. So we've introduced a new term for this F relationship, and it's called corresponding angles. Whenever I think of it to remember, I always think to myself corresponding angles to remember that F relationship. So that might help you to remember. So when a transversal intersects two parallel lines, parallel being key, are the corresponding angles always equal? Well, let's make some F's here and see if they're equal. This F here, was G equal to C? G and C? Well, yeah, they are. What about, let's do some of these backward F's. Were D and A the same? D and A, yeah. Seems to be holding true, isn't it? Are there any counterexamples? If you drew, is there any way we can draw parallel lines with a transversal where those corresponding are not equal? They're actually, I don't think you can do it. And this implies that the conjecture is probably correct. We have not yet proved it, but we are guessing that our conjecture is going to be correct. Sarah says that the converse of Jonathan's conjecture is also true when a transversal intersects two lines and creates a corresponding angles that are equal. The two lines are parallel. Do you agree or disagree? Explain. And I want to spend a second looking at what a converse is. The converse is a statement that is formed by switching the premise and the conclusion of another statement. So here is a premise and a conclusion. If it's raining is A, we are not combining. The converse is if we are not combining, it is raining. And so in this case, our converse isn't true because I might not be combining because there's a football game. I might not be combining because my combine is broken. Okay, I might not be combining because I'm done harvest. But sometimes the converse can be true. And in this case, let's look at this. When a transversal intersects two lines and creates angles that are equal, corresponding angles that are equal, the two lines are parallel. In this case, the converse is true. And I'll show you how they answered this question. I agree if I draw the first line, which will be the transversal, and then draw a second line intersecting the first. So transversal, first line. Then draw a third line, also intersecting the transversal at the same angle. So let's do this angle here. If I draw that same angle, the second and third line are going to be parallel. There's no other way to do it. They would have to be parallel. To use your conjecture about angle measures, so that corresponding angles are equal, hold when a transversal intersects a pair of non-parallel lines. So if we drew two lines that are obviously not parallel, and we drew a transversal, are those corresponding angles going to be equal? We can tell just by looking at it that it's not. So no, this is not true. We should probably take a second to look at some of these other definitions up here. Interior, and this should be a review, interior angles are any angles formed by a transversal and two parallel lines that lie inside the parallel lines. So these are all interior angles right here. And exterior angles are any angles formed by a transversal and two parallel lines that lie outside the parallel lines right there. Okay, so to summarize, and this is what we're going to write, we're going to summarize in our notebook. Our title is going to be 2.1, and we are going to summarize this information. When a transversal intersects a pair of parallel lines, the corresponding angles that are formed by each parallel line and the transversal are equal. So we need to write this down in your notebook. And then I want you to draw all four of these diagrams, really highlighting that F relationship. Oh, that's the wrong F that I'm about to draw. That F relationship. This one as well. So your diagram, in a good diagram, you should show that these lines are parallel. This is the symbols to show that they're parallel. And you should also make sure that you label your angles as they say. Okay, so I'd like all of that in your notebook. And then I would like this. And afterwards, I'd like you to write the word converse after this. So feel free to pause me if I'm going too fast here. When a transversal intersects a pair of lines creating equal corresponding angles, the pair of lines is parallel. This part you don't need to write down, but I would like this in your notebook. And once you're done, I would like you to try page 72, questions 2, 5, and 6. They're not long questions, but they are pretty good to make sure you understand this concept.